Again, welcome to Python Programming Language, CS 101 at Rutgers University. This is the final section of chapter 4. So we continue with the repetition structure, loops. Our main objective in this section is to learn how to use loops to validate an input a user entered, and also how to use the nested loops. And nested loops means we have a loop executing inside another loop. Also, we're going to learn how to use loops for our turtle graphics. So we use the loop to design nice images or shapes. So input validation loops. Here we say that a computer cannot tell the difference between good data and a bad data. Now, if a user provides a bad input, then the program also will produce a bad result or a bad output. Normally, we have the term garbage in, garbage out. If we accept a bad input, the program will process that bad input and give us a bad result or bad output. So it's very important that anytime we design a program, we should have some concept that can make it possible to check the input. If it's bad, then we are not going to accept the input. If the input is good, then we accept the input, then the program can process it. The best way to do this, or most of the time, we use loops. And the common loop is the while loop. So here we say if input is invalid, we need to prompt the user to enter correct data. So in order to accomplish this, we need a while loop. So for example, if input is bad, we are going to display an error message and then receive another set of data. If input is good, we continue to process the inputs. So let's see a very good example here. Here we have a program to calculate the gross pay, salary of an employee. So first thing we are going to ask the user is to enter the number of hours he work. So in line 2, we say get the number of hours work. So we use the input function and we instruct the user to enter the hours work this week. Then we also get the hourly rate or hourly pay rate. We use an input function, then we get the hourly rate. We can see that here we are going to do again arithmetic operations. So we need to convert the data to either integer, or if it's a decimal, we convert it to float. So we use the int and float. As we all know, when we use an input function, the data will be in string, and we cannot use string operation in our arithmetic. I mean strings values in arithmetic operation. So we convert it either to a whole number, which is int function, or a decimal number if we use the float function. So next we calculate the gross pay, which will be hours times the pay rate, and that's the gross pay. Now we need to display the gross pay, so we use the print function. The gross pay, we display the result. Now we know that 0.2f here means, again, we need a 2 decimal places for our answer or for the gross pay. Now let's look what the program output is here. Here we say the user to enter hours work this week. The user enter 400 hours, which is fine because it's a whole number. We ask the user to enter hourly pay rate, which is 20. 20 times 400 will give us 8,000. In this case, the employee will be very happy because 1 week's salary, we cannot get 400 hours a week. The maximum hours we can get for a week will be 24 hours per day for 7 days. So again, to be way less than 400. So this means our result is wrong. We cannot, an employee cannot work 400. There's no 400 hours in 1 week. So in this case, we can use the while loop, and we can instruct the program that while the hours work should be between, we don't want the hours work also to be negative value. So we can use a condition that the hours work should be between 0 to 24 times 7. That's the maximum hours. So this is the best way to do our validation, to validate the input. So first we get the input from the user, then we have a condition. So we know the diamond symbol here for This diagram again means a decision statement. So we're going to have a decision here to make, either true or false. Here we say yes or no. So is the input bad? Yes. If it's yes, then we are going to display an error message. Then we tell the user to enter a new input. Until the user enter a good input, then we allow the input to go through the program to be processed. Next, we are going to talk about nested loops. As we said, nested loops is a loop that is inside another loop. So here we say loop that is contained inside another loop. So example is analog clock works like a nested loop, because we know a clock have hours, minutes, second. When it reach 60 seconds, it will increment the minute to 1. Then when the minute reach 60, it will increment it to 1 hour. So we can see that in a nested loop, the loop inside, if the loop outside is true, it will go inside the loop. Now the loop inside will be executed until it's false, then it will come and increment the outside loop. So here we say hours hand moves once for every 12 movements of the minutes hand. For each iteration of the hours, do 12 iteration of minutes. Same thing with the seconds hand moves 60 times for each movement of the minutes hand. So for each iteration of minutes, we need to do 60 iterations of seconds. So let's see a very good example here. So this program will display a rectangular pattern of asterisks, which we can see right here. So here, the output here, we have 1, 2, 3, 4, 5. We have 5 rows, and the columns are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 columns. Now, how this works, we can see that here we have the program to display the rectangular pattern of the asterisk. So first, we need the number of rows and also the number of columns. So the first input gives us how many rows we want. The second input gives us how many columns we want. Now remember, a clock, hour is the highest, minutes will come before the seconds. So here we need 8 in any amount of rows. So first, our for loop here is about the number of rows. So we say for R in range rows. Then for C in range columns. The reason why, if we are in the first row, we are going to execute the column how many times we want. So let's say if the column is 10, then in my first row, I'm going to execute, you see the first row, we are going to print only, we will only be in the first row. But the column, the nested, the loop inside, which is the for C in range columns, is going to execute 10 times until it becomes false. Then it will go back to the outer for loop, then increase it to 2, which will be second row now. Then execute 10 times, increase it to 3, will be third row. So we go through that until we finish. So that's the statement here. Here we enter 5 for the rows. So we are going to get 5 rows. Columns is 10. So which means the first row we have 5 here. So we start with the first one. We go from 0 to 4, 5. Then here we have 10. So that means we go 0 to 9. So we are going to execute the inner for loop 10 times. That's why we have 10 columns for the first row. Then we move back to the outer for loop for the rows. Second, it's okay. 10 times again. So we do this until when we reach the row to be 5, the loop will, anytime the outer loop condition is false, then the inner loop will not execute. We can't go in no more. So if we enter 5, it means our rows will be 0 to 4, or let's say 1 to 5. So the 6th row will not execute. Then we come out of the loop. Then every time we execute, we can see the first print statement will print the asterisks for the columns, because the print statement here is executed, is only seen by the inner loop, which is for C in range columns. So after the condition of C become false, we print. What this print will do, every time we print the number of columns finished, this print will move the cursor to the next line. If we don't have this print here, it means we are going to have all the asterisks on one line. So again, for R in range 5, because the input is 5, for C in range 10. So we start from 0. Here we have 10, so we go from 0 to 9. And what we are doing, this print asterisk is inside the inner loop, the for C in range. So it will print all the way until the condition is false, which in this case, if I have 10, then that means it will print 10. If it's 15, then it will print 15. That's why our output here, we have 10 columns for each row. The rows are 5, so we have 1, 2, 3, 4, 5. Now, how do we move from first row to second row? Is the print statement here. We can see that this print statement is for the outer for loop. The indentation is for the outer for loop. Okay, so that's the concept here also. So we start with a program. Is there any another value in the hours list? No. If no, then we end. If it's yes, then we continue, assign the next value in the hours list to the hour variable. Is there any another value in the minutes list? Yes, then we assign it to the minutes. Then we go up to second. This is the concept of, again, nested loop for a clock stimulation, flowchart for a clock stimulator. We know a clock have hours, minutes a second. So first we check with the outer one, which will be hours. Then the next will be minutes. The next will be seconds. So we have 3 different conditions. So key point about nested loop. Here we say that, as we mentioned in our first program example, designing the pattern output program. Again, let's go back here. This is the whole concept. Nested loop means the outer loop will execute first. Then we go to the inner loop and do whatever we want to do. When the condition becomes false, it will come back to the outer loop and continue doing that. When the outer loop is false, then the loop will not work no more. We can't go inside the inner loop. And that's the condition given here. The inner loop goes through all of its iterations for each iteration of outer loop. So when I'm in the first row, I will go to the inner, go through all the number. The row is 5, but I won't go through all the 5 at a time. I'll go through the outer row 1 at a time. But when I go through the first row, in the column, we have to go through all until it becomes false. Then we go outer, second row, third row, etc. So yeah, inner loop goes through all of iteration for each iteration of outer loop. So the column print all the 10 columns for each row, then move to the next. Now, inner loops also complete the iteration faster than the outer loop. So the total of iteration in nested loop will be the number of iteration in inner and also times the number of iteration in outer. So you can see that if we count all the asterisks, it will be 50, because we have, again, 5 rows, 10 columns. So 10 times 5 is 50. Next, we shall go through using the total graphics with loops to draw a nice compressed diagrams. So here we say we can use loops for a total to draw both simple shapes and also elaborate the designs. So for example, the following for loop will iterate 4 times to draw a square that is 100 pixels wide. So here we have for X in range 4. So we have 4 sides. The range gives us 4. Then we have total dot forward 100. Then total dot right 90, the angle. So when we move, start and we move first 90 degree down, 90 degree again, 90 degrees. So that's why all the 4 sides, the degree, total dot right 90 is the degree. Now this is just using only one loop. Now we can also use for loop, one for loop also. This time we are going to have 8 times to draw octagon. Octagon have 8 sides. This time the angle is 45. So we can see that each side, the joint is 95 throughout. So the for loop make it possible for, now previously, if we want to draw the 4 sides, then we have to keep writing the forward, total dot forward 100, total dot right 45, total dot forward 100, so we have to write all the 8 side code. But here we are writing only one code, and then the loop will execute 8 times because the range is 8 from 0 to 7. Same thing also here, we can create interesting designs by repeatedly drawing a simple shape with a turtle, then tilted at a slightly different angle each time it draws the shape. So we can see this is the shape we are having from this code. Here we say the number of circles in this is 36. The radius is 100, the angle is 10. Angle means the angle to 10. As we saw previously, angle can be 40, any angle to 10. So here we say for X in range number of circles, which is 36. We want to draw a circle with a radius of 100. Then we move the angle of 10 for each circle is 10. So we can see, looking at the shape, we can see that they are just circles, but the turning angles are different. So we see different shapes together. Next, also, we can have a nice shape here. This could draw a sequence of 36 straight lines to make a starburst design. So here also we have the start X and Y is -200 and 0. The number of lines is 36. The length is 400. This time the angle is 170. So we start with the total dot, hide the total first. Then we bring the pin up, total dot pin. Then we go to X, the start X and Y, which would be our starting point, coordinate of 0 and -200. Then we move the pen down. Now we're ready to draw. So we say for X in range, the number of lines is 36 again. The total will move forward by the line length, which is the line length is 400. Then the total dot left, the angle is 170. And this will be again the whole concept again, concentric circles, the number of circles, the starting radius. Then we have offset 10, animation speed 0, the speed, the total dot speed, total dot height, the total first. We set the radius as a starting radius, which is given to us to be 20. Then we are going to draw a circle. And this circle also is same as the previous question. We can see the number of circles is 20. So we draw 20 circles. The radius is given already. And we start to get the coordinate for the next circle, the X coordinate and Y. Then we calculate the radius of the next circle. Then we position the turtle for the next circle. So the pin up, go to S and Y, then the pin down, then we can draw a nice shape. So this is again a circle, but we can see it's reducing because from the question here, we have an offset. The offset is 10. So X is coordinate is okay, but the Y coordinate each run, it will reduce by 10. So that's why our circle is getting smaller and smaller. So again, we can see the simple one, a very good one we should understand is something like this. It's very simple. We should get the whole idea. How many circles I need? What is the radius? What is the angle? So I want to repeat, draw a circle, repeat it 36 times. The radius of the circle is 100. And kind of making an angle, we can change the, again, you can change the angle and then you see the different shape, how the circles will be. So we can see the shape. So the last program is this. So we can also, the same, what we just went through, this is the code, the full code now. So again, the number of circles is 36, the radius is 100, the angle is 10. We don't have no, and the animation speed is just 0. Then we set the total speed to 0. We draw the 36 circles with the total tilted by 10 degrees, which is giving an angle after each circle is drawn. So for X in range, the number of circle 36, radius 100, the angle is 10. The next one, this program will draw a design using repeated lines, import total. Then we have our S and Y coordinate again. The number of line is the same, 36. The length is 400, angle is 170. The animation is 0. So we hide the total first. We move the pin up. We go to the starting X and Y coordinate. Then we put the pin down. Our animation speed is 0. Then we have our loop now for X in range 36. So we are going to draw 36 lines. The forward, the line length is given to be 400, and the angle also is 170. And this is what we get, the shape. So again, that will be the conclusion of these lectures. The goal of these lectures again is to go through the loops. In our previous lectures, we went through the while loop, for loop, etc. with Python. And this time we learn how we can use the loop to validate an input, and also the nested loop, which is very important, and also how we use the loop in Turtle packages or Turtle graphics. Again, thank you for your time, and see you in the next lectures. So our next lectures will be chapter 5, which cover the functions.